a slight bit of review from where we were yesterday. We quit on the problem before this one. There were actually two more problems I kind of would have liked to have done last night. Now, both of these are in the video that I posted last time. Simply because this problem, 2i plus I, or 2 plus I over 3 minus 2i. Okay, once again, for those of you who were not here, if you've got a complex value in the denominator, the strategy to get rid of the I, because thou shalt not have an I in the denominator, is to multiply that by its conjugate. Well, if you do that, you also have to do the same thing up here. And we'll put parentheses around these. Now, once we've got this, we can actually multiply this stuff out. One way of doing this and showing the work, and I think I'll do that because I'm known to do it this way because it's convenient. Let me drop this down to 2 plus I here over 3 minus 2i there, and put 3 plus 2i over 3 plus 2i here. Sometimes I work the top and the bottom at the same time. Okay. When I say work it, I'm fundamentally meaning simplify, multiply it out, that kind of stuff. This being a conjugate, my answer is going to be in the form a squared minus b squared. So first term squared is 9, and minus last term squared is 4i squared. Well, this becomes 9 minus 4 times -1, which becomes 9 plus 4, or 13. Okay, and I don't necessarily need to circle that. That's as far as you can take this denominator for now. Well, you can also simplify, or you must also simplify the numerator. In this case, it's going to be just old style distribution or FOILing, whichever you're more comfortable with. 2 times 3 is 6. 2 times 2i is 4i. I times 3 is 3i. And I times 2i is 2i squared. This in turn can become a -1. Okay, these two can be combined. So I've got 6 plus 7i minus 2 minus 2. Well, 6 and minus 2 gives me 4 plus 7i. Okay. So basically, I've just simplified this. I could have gone that way, but I would have had to do a whole lot of rewriting in the steps. This is just a lazy man's way of doing it, okay? So all of this works out to 4 plus 7i over 13. Well, there's one more step. This thing has to be in the format of a plus bi. Right now, it's not. So we have to uncommon denominatorize this and make this 4/13 plus 7i over 13. That is the answer. Okay. Now, if you see a conjugate in the complex in the denominator, what is going to be your plan? Multiply it by its conjugate. That is worth 2 points by itself, even if you make errors after that. Okay. Okay, the final one out of this particular set. We got to simplify this thing. Well, in this particular case, we got to deal with that. So we've got 6 plus an I we've extracted. We're going to make this into 9 times 2, right? And we're going to extract the 9 to a 3. And I still got a radical 2 there. All over 9. Okay, everyone understand exactly what I did here? Okay. Now let's finish cleaning this thing up. 6 plus 3i radical 2. And I'm going to put this over 9, and I'm going to put that over 9. In other words, I uncommon denominators. Now, if you wanted to write this and put it all over 9 and then do this step, that's okay. You can put in that extra step if you wish. Now, this will reduce to 2/3. This will reduce to 1/3. I radical 2. Well, do you need that 1 there? No, so I would just show it this way. I'll put that 1 hidden there, just so you'll know it's there. But 2/3 plus I radical 2 over 3. If you wrote this 2/3 plus radical 2 I over 3, it would not be wrong. Okay. Just be sure that this doesn't extend over that. Now, that's the end of that chapter in the book. What?
On that, so you said 9 out of that 13. Wouldn't there be more than 2? There'd be like 4, wouldn't it? Or wait, is that 13 or 14?
That's 18.
I'm so sorry. Never mind.
That's 18. 9 times 2.
Yeah, sorry.
Okay, that's fine. Any other questions? Well, I'm glad you asked.
Yeah, no, sorry, my brain.
That's the danger of overriding also. Okay, so let me get out of this PowerPoint and say bye-bye and start the new one.
Oh, boy.
Okay. Now, some of these things I've alluded to you already, and I've mentioned a few times that this is a future cure for things. Okay. I guarantee you all of what we're about to do is easier than what we did in exam 3. Okay. Now, back to here. Quadratic equations, that means they got a second power leading term, right? They either make W's are arches. Okay. Now, so basically, this is about that. Literal equation means just solving for a certain variable. We've had those that were simpler before. So these are different ways of solving quadratic equations, just two methods. Okay, I don't take a whole lot of faith in this. Basically, if you got a square term on one side and numbers on the other side, it's saying you can take the square root of both sides and you will get a plus or minus number side. I'll illustrate that more as we go on. Okay, this can be written as that. Now, why?
Because any number squared on itself, whether it be positive or negative, is going to be positive.
Exactly right. Any squared number could either be positive or negative. When you square it, the negative goes away. Okay, so let's look at this one. Use the square root property to solve this equation. 4p squared equals 9. Now, technically, we could divide both sides by 4, but it's not to our advantage because I really don't want to have 9/4, although I can. Okay, and they did. I'll work it without doing it this way in a moment. Now, I've got this thing. This radical you see here, this radical you see here, and the plus and the minus are a follow-on step. First, they did the division. Then they took the square root of both sides. Why? Because that is a square. How do you get rid of a square? Take the square root of it, and you end up with whatever is in. Okay? Now, in this case, we know that that's going to be 3. We know that that's going to be 2, right? So the answer of this, square root of p squared is just p, is either positive 3/2, or the answer is negative 3/2. Okay. Now let's test this to see if it's true. I think they may actually, nope, they don't check it. So let me check it with you. If it's positive 3/2 right here, if it's positive 3/2, 3/2 squared is 9/4, right? And then we got 4 times that, and the 4's cancel, and I get 9 equals 9. Now, let me show you how I probably would have worked this problem. If I had this problem, 4p squared equals 9, since that is a perfect square, and only if it's a perfect square, I would just leave it there for the moment. Then, as my next step, I would take the square root of all of that and the square root of this plus or minus. Okay. Well, what's the square root of 4? 2. What's the square root of p squared? P. And over here, I get plus or minus radical 9. So 2p equals plus or minus 3. And now I divide both sides by 2. So I get p equals plus or minus 3/2. Okay. Now, that's how I probably would have shown the work myself. Either way is perfectly okay. Okay. Now, questions about this problem again? Yes.
Why wouldn't you do both square roots at the same time?
What do you mean? Why wouldn't I do
Why
both?
would you leave the plus or minus square root of 9 instead of Point here is 2p.
You wanted me to make this for 3 up here, right then? You can. You can. Usually you got more complicated stuff on this side. This is kind of why I left that there. Okay, well, let me erase this and let's go on. By the way, what is this? It's called either the property of square roots or the square root property. What we call this method of solving. Now, here's the original problem up here. 25a squared equals 16. I take the square root of this side. I take the square root of 16 plus or minus. Now, that basically gives me two problems. It gives me the plus side and it gives me the minus side. Okay, so this gives me 5a equals positive 4. That over there is I have the 5a again equals the negative 4. Hence my two sides. Same thing we have to do on absolute values, right? Okay, so divide both sides by 5 and I get 4/5 here. Divide both sides by 5 and I get negative 4/5, and that is my answer. Go ahead. You have a question.
So after you find the square root, like 25 and 16, then you split it?
What?
Then you split it?
Yeah, basically at the same time. I mean, if you wanted to write a step up here, if you wanted to write this step, 5a equals plus or minus 4 as a step before you split it, you could. But you don't have to, but you could. Okay. Did that answer your question? Yes.
So why not just leave it in the plus or minus?
Because I won't give you a points for it. I mean, that's a cheap answer. But I mean, you can further simplify it. So you must, because you always need a 1a, 1x, 1 whatever variable equals. Okay. And that kind of forces you to do the two ways, the plus side and the minus side. Now, when would you ever encounter the use of a problem like this one? We have had quadratics that look like this, right? And we've tried to factor. Okay. This method is used when you're missing the middle term. X squared plus 3, and this is a totally different problem. And this one's going to have a little trick in it that I haven't shown you yet. Okay. So I don't have the middle term in this one. So that's when you're going to use this. So you take this 3 over to the other side. X squared equals, in this case, negative 3. Uh-oh. What's going to happen when I take the square root of both sides? I'm going to get a negative radical, which means I'm going to get an imaginary. Okay, so let's do that. Square root here, square root there, plus or minus. Okay, this gives me x. That gives me plus or minus I radical 3, because 3 won't break down. Okay? That's all I can do with this one. This one I can leave in that form. Because I can't do anything with I, and I can't do anything with radical 3. Okay? So I don't know if that's kind of what you were leaning to earlier or not, but that's when you can leave it in plus or minus form like that.
Even so, for your first example, you notice it's equal.
Actually, your answer right here also could have been shown as plus or minus 4/5 as a final term. This is just how you get that plus or minus.
But you can have A equal plus or minus.
You can.
For the final answer.
Yeah, for the final answer. Okay, I thought you were asking why did I do the 2 separate parts?
Oh.
But if you can write that as a final answer, why bother doing it?
Because
To make sure.
To make sure that you got the right numbers, because these all won't always be the same numbers. Sometimes these will be different, totally different numbers. Okay? And that's why. Okay, good. All right, let's go on then. But this is when you tend to use this method. Okay? And by the way, there's another way that will work with both kinds. One where you got all 3 parts and one where you just got the 2 parts. And we'll do that in a few minutes. Okay, here's another one. See, I'm missing my middle term on this thing. Now, on this one, I want to take the 75 over. And I also want to get rid of that 3 because it's not a perfect square. So I'm going to divide both sides of this by 3. 3 goes into this 1 time, 3 goes into that 25 times. 3 times 25 is 75. But once again, I have a negative radical. So I'm going to get an imaginary again. Okay. Well, what do I do in this thing? This one is just x. Here, I have the I extracted, and I can extract a 5. And this has got to be a plus or minus, so the answer is plus or minus 5i box. Okay. Now, I'll erase my scribbles and put theirs up. Okay. And here's the check on that one. In case you want to try to see it, you can actually check with i's. We replace x with I, the positive side right here. Okay. That squared gives me 25i squared. I squared is -1, gives me -25 times 3 is -75 plus 75 is 0. Bingo. What? Okay. You can also do the negative side. And in this case, still equals 0. So both of those are correct answers. Now, I'll tell you something. If one of your i's is a correct answer, the conjugate has to be a correct answer. Because there's always got to come in pairs, the conjugate pairs. Okay, so what about this one? That one would be kind of a pain to try to factor. Actually, not that much. That one could be factored real easy. I'm going to show you 2 ways of working this one. Yeah, let's see. I'm gonna factor an 8 out of this. And I get that. But that's not a conjugate. Because it's not a minus in the middle. So we can't use the conjugate rule. But we can do I've already divided 8 out of both of them, this and that, so I don't need to do it again. So I took it over here, add -9 to both sides. Okay, so square root of both sides plus or minus x here plus or minus 3i. Okay. Now, the only thing that's different is I could have had the 8x squared take the 72 over like that, take this over here, and then divide by 8. And I would have gotten the same x squared equals -9 that I had here. Okay, so that's the only thing that's different. And I don't know that that's a significant difference. Pay me now or pay me later. Or in this case, divide me now or divide me later.
So,
What?
so what happened to the, when we were doing the first way, so where did the 8 go?
It's already divided out of both of them.
We factored that 8 out of the beginning. It was as if you just making this.
Dividing it out of both of them. 8 goes into 8 once, 8 goes into 72 9.
Oh, okay. Understood.
All right. Square root property to solve this one. This one has a slightly different look, but it's still something squared equals a number. Okay, so it still fits the general format. Well, guess what I do? I take the square root of this whole thing, and I take the square root of that plus or minus. That gives me w plus 3, and this gives me plus or minus the square root of 4 times 5. I can extract the 4, get a 2. So I've got that. Now, minus 3. And I can't subtract 3 from that. So I get a minus 3 over here. Okay. And this is starting to get complicated. Where do I put that plus or minus? So actually, before I do this, I'm better off doing this. Okay, and that. Now, why do I have, oh, whoops, I don't need this yet. I don't need this yet. Okay. I'm better off Okay, let me get it right. There, now it's correct. Here's the positive 2 radical 5, here is the negative 2 radical 5. Now then, I can take the 3 over, minus 3, and I get W equals negative 3 plus 2 radical 5 for this answer. And over here, I get minus 3, W equals negative 3 minus 2 radical 5. Now, this answer could be written as W equals negative 3 plus or minus 2 radical 5. It could be written as that, yes.
It's not, there's that, other three always gonna be moved over. Not that it's going to be different things.
Over to here.
Is there gonna be times where it's gonna be extended?
No, because you've got to get one W by itself. Okay,
You're not combining the eights.
you cannot. Because this radical behaves like a variable. Okay. You couldn't combine negative 3 and 2x. So you can't combine negative 3 and 2 radical 5. Because radicals and imaginaries behave like variables. Okay, can I erase? And there's their work, which is fundamentally the same as mine. Now we're going to go to the final way. By the way, this quadratic formula that I'm going to show you also will work on the others. You just let B equal 0 when I show you how this formula breaks out. The quadratic formula happens to be in your handout packet. I've got a handwritten list of formulas. They're probably like page 30 or something like that. And it's on that sheet. You must memorize it. You must memorize it. Both for this class and 111. Yes.
For the purpose of the test, can we write the equation down on the top of the test before we start?
I don't care. Now, for the purpose of the test and homework and everything else, I want you to write that equation down at the top of the problem before you work.
Okay.
Okay? Now, completing the square is something you guys don't have to do. Last time I used these slides for this class, you did have to do it. Besides, I invented an easier way. So, let me get rid of this stuff and skip through all of that. Completing the square can, depending on the numbers, can get quite nasty. You know what, I want to make absolutely sure they didn't put that back in because I think they took it out. Because if they did put it back in, then unfortunately I will have to do it. This is gonna be the right one. Okay, that's what I thought. I thought I didn't have to do that. Correct. We're very fortunate. Okay, so let's continue through here. What's going on with this? We do have to do this literal equation business, so I may have to go back to that. Okay, so here's the general format for a quadratic formula. You know, 3x squared plus 2x plus 5 equals 0 kind of thing. Okay, that's the A term, the B term, the C term based on location. Okay, here is the quadratic formula. That's what you got to memorize. Negative x equals, what this does is it gives you the x values from one of these equations. Okay, without having to factor it. Negative b, negative whatever that number is, plus or minus b squared minus 4 times a times c all over 2a. Okay, that's called the quadratic formula. It's probably one of the 3 or 4 most famous formulas in all of mathematics. Okay, Pythagorean theorem being one of them. Now, if we've got this problem, we got to get that 5 on the other side, so this thing's in standard form. So that's in standard form. 2 is A, negative 3 is B, negative 5 is C. Here's the formula. As you are working these kind of problems, I want you to write down this formula just like this every time. That's worth 1 point by itself, if that's the proper way to solve the problem. Okay? Then the next thing you do is you do your substitutions. Put a parentheses around every number that's substituted. For one thing, that'll help you not to make sign mistakes. Everyone got this far? Does everyone understand where the numbers came from? That's more important. Can't use a calculator, put it away. Or a phone. Oh, okay. I'll go along with that. Okay, so now that we got the substitution done, we got to simplify it. And what was this? This is just reiterating the formula, although it's written in that one. Okay, so here's what we had as our bottom line before. Negative times negative is positive. I've got the plus or minus. Negative 3 squared is going to be positive 9. And here I've got negative 5 times 2 is 10, times 4 is 40, times a negative is positive 40, all over 4. Well, we got to add those two together. We get 49. And we got lucky. Because 49 is a perfect square. So that means we can get rid of the radical altogether. If that's not a perfect square, then we can't get rid of it. We have two choices, either end up with an imaginary or end up with a decimal or fraction value, if we wanted to graph it. Okay, so that's 7. Now I've got two problems again, the plus and minus side. 3 plus 7 is 10 over 4, reduces to 5 halves. 3 minus 7 is negative 4 over 4, which is negative 1. And they're showing the 2 halves. And this is the way I usually show the 2 halves. This one being the positive side, this one being the negative side. So there are my two solutions. What are those? Those are the 2 points for this equation's 5 halves. Okay? 1 half, 2 halves, 3 halves, 4 halves, 5 halves. Negative 1, which happens to be 2 halves in the other direction. Those are these 2 points on that graph that this thing is going to go through. Okay. On that last stuff, when we got x equals sometimes 2 values, those are the points on that graph that that quadratic goes through. That's what those things really are. Okay. If I still had the original problem up here, I can see what the y-intercept was, but I don't have it up here anymore. Okay, here's another one. First, we take the 4 over, so it's in standard form. That would be ugly to factor, wouldn't it? So maybe you wouldn't even want to try to factor that one. Maybe you would want to just throw it into the quadratic formula to start with. Okay? And I'm going to show you a trick at the end of this one. What if you got that problem and the problem said factor? Well, these aren't factors, but I'm going to show you how you can get them from this. Or if the problem said solved, then that means it wants x equals. Now, let's go on down. X equals negative b plus or minus b squared minus 4ac over 2a. Negative 5 is the b, here and here. 6 is the a. Negative 4 is the c, and again, 6 is the a. Negative negative gives me plus. Negative 5 squared is 25. Negative times negative is plus. And 4 times 6 is 24, times 4 is 90. Okay? Or 96, actually, I think that is. I think that's a 96. Okay? Yeah, it is, because 16 times 6 is 96. That's a 6 right there. Okay, so anyway, 25 plus 96 makes 121. We got the 5 and the 12 out here. 121, if you look at your exponent sheet that I told you to start getting used to learning and recognizing, is 11 squared. Okay? So now I've got 5 plus or minus 11 over 12. That generates my two problems. One time I get 4/3, the other time I get negative 1/2. Okay? What are those two numbers represent? Where it crosses the x-axis. Okay? What if this problem, instead of saying solve, said factor? I'm going to tell you how to cheat. If you don't think you can factor that, and it'd be real tough, admittedly, but you could. Watch this. If x equals 4/3, then x minus 4/3 equals 0, right? That's a factor. If x equals -1/2, then x plus 1/2 equals 0. That's a factor. Now, if you truly factored it, you would have a different answer than these two. If we take this, x equals 4/3, and we multiply both sides by 3, we would get 3x equals 4. Take that over, and we would get 3x minus 4 equals 0. This and that are the same value. Okay? Now, if you truly factored it, that's what you'd get when you do the cross product business. On this side, what would you end up getting? Well, if x equals -1/2, okay, I'm going to take both sides times 2. 2x equals -1 equals -1. And then I'm going to take this 1 over to the other side. So 2x plus 1 equals 0. So if the problem said factor, you could throw it into the quadratic, get the x values, and back work it. Cheat and get the factors. That's your safety valve, guys. That is your safety valve. When I tell you you got to factor something, you can't. That's your safety valve. Okay. Now, what about this thing? This one would be easy if I didn't have that 11 out there. If I didn't have that 11 out there, if I had a 0 instead, then my answer is x equals 0, x equals +6. Now, everyone know how I got that +6? X minus 6 equals 0. X equals 6. Add 6 to both sides. Okay? If that were 0, but it's not. So, what we got to do on this thing is we got to put it in standard form. Now, this could actually be factored. I think. Maybe not. Let's see, what are the factors of 11? 1 and 11. There's any way you can get a 6 out of that. Okay. So that's thing isn't going to factor anyhow. But we can throw it into the quadratic formula. We don't even have to factor the -1 out first. Although we could, they did. That's optional to do that. Okay, it'll work without factoring that out. Well, here's the formula again. So we put it in. And when we put it in, they didn't show the steps. Here's the substitution values. There's the substitutions. And you get ultimately, whoops, probably too fast. This one's turning out ugly. By the way, this business right here, all they're doing is they're showing that they're going to divide 2 into 6 is 3, and 2 into 2 is 2. Or is 1, I mean. 2 into 2 is okay. And then they're going to cancel those 2's, which means you got rid of them. Here's the last step on the one before. You still weren't there. Okay. All right, I'll slow down. I'm just so excited. Tell me when I'm safe.
This is going to be a stupid question. How do you get the 2 in the
That's a good question. I don't remember the original problem. Because 2 times A and A is 1.
Oh, okay, because I was in the middle of writing down that stuff and you just blitzed through it. Not confusing.
Oh, I'm sorry, just real quick. Did you get that 2 off on the side?
Here.
Yes.
Okay, now, let me just go through something. If I were doing this problem, I wouldn't do that step. I would do, this goes into that once, this goes here 3 times, that goes there 1 times. That's what I would do. Now, what they did is they factored a 2 out of 6, got given a 3. They factored a 2 out of 2, giving a 1. And then they're going to cancel the 2's. Okay? Yeah. Now can I go on? Okay, so here's where we left off. Now they're factoring out the 2's. So I get x equals 3 plus or minus radical 2i. Now, can you leave it this way, or do you have to put it that way? As far as I'm concerned, you can leave it this way. Okay, what about this one? Well, here we got to distribute that negative y and move the 12 over. So we got this thing in, oh, what happens here? Oh, I get to work this one. So I get negative y squared plus minus 4y minus 12 equals 0. Okay. What if I just leave this and don't factor out a negative? Let's see what I get. Okay. So A happens to be -1 in this case, right? Oh, that needs to be a plus there. No, it doesn't, it's a minus. Okay. So using that, I would have x equals minus -4 plus or minus square root of -4 squared minus 4 times a, which is -1, times c, which is -12, all over 2 times a. Okay, so this is 4 plus or minus square root of 16. Minus 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 gives me a minus. What?
Is that whole line of there be supposed to be negative? I don't know what the-
When I take this times that, that's where that comes from. Okay, minus 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 gives me a minus there. So 4 times 1 is 4 times 12 is 48. All over -2. 4 plus or minus -32 over -2. Okay. This is 16 times 2. So equals 4 plus or minus 4i radical 2 over -2. Okay. And 2 will go here, or -2 will go here. Once -2 will go here -2 times. And here -2 times, which is getting a little weird.
Yeah, but you still have plus or minus, so you really did it.
Yeah. So we got -2 plus or minus 2i radical 2. Now let's see what happened if we factored out that 1 in the beginning. Okay, here I'm going to factor out the 1, which gives me y squared plus 4y plus 12 equals 0. So x equals -4 plus or minus square root of 4 squared minus 4 times a, which is 1, times c, which is 12, all over 2 times 1, which gives me -4 plus or minus square root of 16 minus 48, all over 2. Okay, -4 plus or minus square root of -32, all over 2. Okay. Look at this one, look at that one. Signs are opposite, aren't they? So ultimately, the signs are going to cancel out. But I'll go ahead and carry this to finish. Okay, so this one again, 16 times 2. So I've got -4 plus or minus 4i radical 2 all over 2. This 2 goes once into that one, -2 times. This 2 goes into that, positive 2 times, I've still got the plus or minus, so it's -2 plus or minus 2 radical 2, or I radical 2. So does it matter if you factor out the negative first? No. You just got to be careful if you leave it in there on your signs a little more. Just got to be a little more careful. But I wanted to show you that you'll still get the same answer either way. Okay? Because it's important that you have that level of confidence to know that. Okay, questions about how you use the quadratic formula. It's basically a plug and play, a sub and solve. What's the hardest thing about it? Probably memorizing the formula. They used to have a little, oh, I can't think of what they call them, where you make up rhymes or things to help you memorize. And there was something, yeah, mnemonic. There was a bad boy who couldn't make up his mind about, and it's harder to learn the stupid mnemonic than it is just to learn the formula. Yeah. Okay, now, I am going to tell you one thing about this. Can I uncommon denominator-wise this? Can I? Can I put the 2 under this and put the 2 under that? See this formula right here, this piece of this formula? That's how you find the vertex and the line of symmetry on graphs from standard form. And this tells you the spacing from that line of symmetry that the points are. Okay? Probably most math books and math teachers aren't going to tell you that. But this formula we're going to have, and you're going to have to know eventually. So I just wanted to show you that real quick. Okay. Fortunately, we don't have to do applications. I'm sure that breaks your heart. Well, let me skip through some of these applications. Okay, 16t squared, anytime you see 32c squared or 16t squared, you're talking about gravity. Okay, here's another one. Basically, is you shoot a rocket into the sky, it lands, I don't know where. Okay, well, this tells you where. That's the formula they used in the movie October Sky. That 32g squared or t squared, that was the formula they used. With the velocity and the seconds to the height, they were able to back figure it. Okay, discriminant. This is something you'll be tested on, possibly on the final. The discriminant, you remember how I broke this into 2 pieces a moment ago? I was kind of prepping you for this, except we don't put it over the 2i. Now, what this is saying is that the stuff under the radical, without working it out a whole lot, without actually taking the square root, will predict what kind of answers. Sometimes we got just one answer for each side, the plus or minus, right? Sometimes we got something with a radical in it on both, a plus or minus. And that's two real numbers. They're real numbers. Radicals are. Because they can be graphed. Square root of 3 is 1.732. You can graph it. Okay, square root of 5 is 2.232. You can graph it. Okay, but i's you can't graph. They are imaginary numbers. When we got one imaginary, if you remember, we always got its conjugate, didn't we? We always got the opposite one. Okay, when we got radicals, we always got the opposite one. So anytime you get a radical answer, you're going to have two real numbers. Anytime you have an imaginary number, you're going to get two real numbers. Now, what if you get 0? Then all you got is the stuff out front, because the radical totally goes away. The square root of it. Okay, what if you get a perfect square number in there? Like earlier we had a, what do we have, a 25 under there? And the answer was 5. And we had whatever negative b was plus or minus 5 over something. How many answers did we get on that? 1. If it's a whole number. No, if it's a 0, we only get one answer. If it's a perfect square, we get 2 real numbers. If it's a radical, we get 2 irrational. They're real, but they're still irrational numbers, meaning they'll never become a non-repeating decimal. And if you get 2 imaginaries, or if you get a negative, then that means that you're going to have imaginaries under the square root symbol. Now, that's what this whole thing is telling you. Now, let's look at this. Here's an equation. The discriminant is just the b squared minus 4ac, the part that goes under the radical. Okay? Now, in this case, b is -5, a is 2, c is 9. 5 squared is 25 minus 72 gives me an answer of -47. Now, if that were under a radical, if it were, okay, then what kind of answers are you going to get on the problem? You're going to get a pair of imaginaries, a pair of imaginaries. It's important that you say there are 2 of them. Okay. Let's go to their next example. Here it just says you got a pair of imaginaries. Anytime you get a negative number, you're going to get 2 imaginaries, because when you throw the radical over it, they go imaginary. Okay, what about this one? Well, let's move those 2 pieces over to the other side. Okay, the discriminant in this case, b is 1, a is 3, c is -2. 1 squared is 1. 3 times -2 is -6 times 4 is 24. Here's that negative times the negative of these 3. Ultimately, you're going to end up with a positive 24. You understand that, right? Which gives me a total of 25. I have a perfect square that would be under the radical. So I'm going to have 2 answers. I'm still going to have a plus or minus, but it's actually going to be real graphable whole numbers. Okay? Or just simply 2 real numbers. That's what that's saying. They're calling it rational numbers because it could be in fractional form. Okay, here's another one. There's the equation. Here's the discriminant. Here's the 6. Here's the A, and here's the C. Multiply them out, we get 52. 52 breaks down into 13 times 4. You all know the 52 card pickup, 13 suits and 4 of each. Card math. Okay? That'll come out. That'll come out. So ultimately, you would end up with this, whatever negative B is, plus or minus, you know, that stuff. But the point is, in this case, you have a non-perfect square, a positive non-perfect square under the radical. What does that mean? We're going to end up with a radical answer, which what do we call the set of radicals that are not perfect squares? Irrationals. Irrationals. Okay? So those are the answers that they're going to ask you on your test. They're going to give you a problem. And they're going to say, what kind of answers are predicted from this problem? If you get a 0 when you're done down here, there's only one answer and one alone, because the whole radical side goes away. If you get a perfect square here, then you just got 2 real numbers. If you got an imperfect square, then you're going to get 2 irrational numbers. And if you get a negative something, then you're going to get 2 imaginaries. And that's everything there is to know about discriminant. Okay. Well, here's just more examples of this. Here I got a 0. Okay. So they're going to tell you solution type is you only get 1 rational or 1 real answer. If you say real right here instead of rational, I'm not going to count you wrong. But rational is the technical answer because it could be a fraction. Okay, so there's just more practice problems on. Here's one. In this case, discriminant, you get an answer of 5. What does that tell you? 5 is an imperfect square. So you're going to get 2 irrationals or 2 radical answers. Okay, and here's more of those. There's working it out actually. And that gives you the points. Now, whoa, where did this stuff come from right here? Here's those 2, this one and that one were the 2 x values you got. Now, where did these zeros come from? Because the question was, where do they cross the x-axis? Okay, what are the x-intercepts, or what are the solutions, or the zeros? All the language that means the same thing. On that x-axis, y always has to be 0, because it isn't up or down, it's on. Well, here's another one. There's the graph of the thing. Right here's your 2 points. Okay. Now, what is this business? This is finding the y-intercept. To find the y-intercept, you can do it the hard way or you can do it the easy way. At the y-intercept, x has to be 0 because it's neither left or right. Okay. So you can replace all of the x's with zeros, and what do you got left? Or you can just look at this number and say, ding, I got it. Without going through all of this nonsense. Okay? Okay. This one, find if there are any. Now, this is a sneaky problem that's saying if I get imaginary answers, meaning a negative discriminant, then there are no x values on the x-axis. Okay? Because imaginary values are what you get when the whole loop is above the x-axis or below the x-axis and never crosses them. Okay? Does that make sense to you? That's why they're imaginary, because you can't graph an x on the axis for those graphs. Okay? So this is just a sneaky way of asking you, if you get a minus discriminant, then there are no x-intercepts. If you get anything else, then yes, there are. They might be nasty, but you get them. Well, here's more. Okay, see, got that negative value? So there are no places where the graph crosses the x-axis. Okay, well, one thing I need to go back on just a moment, okay, is I need to talk about, I gotta go way back here. No, keep going, keep going. Keep going. Be patient with me, please. We still got 4 minutes left, or 3. 2, or whatever. Literal equations. Okay, we've done these before. What do? We isolate whatever variable they tell you, and then get everything else on the other side. We've done these before. I just needed to remind you, that's all. Okay? I don't think I need to reteach that whole subject, especially in 2 minutes. Try? Okay. This one says, okay, look at, the only thing difference this time is you might have to deal with a square.
Yeah.
Whereas before, we never had to deal with a square. Well, in this case, it's telling us find t, isolate for t. So we've already got that. But how do we get rid of that t? Square root of this, square root plus or minus of all of that. This gives me t, and this gives me plus or minus the square root of d over 0.7. Uh-huh.
7.
Oh, okay. Thing.
Okay. That's the only difference is on the isolation. If you got a variable, you may have to take square root plus or minus on both sides. That's the only thing that's new this time. Okay, and with that, good night.